Hello and welcome back to another Beyond Our Value, uh, brought to you by TimberHP. So I'm going to be on here. My name is Dan Edelman with TimberHP. I'm a sales manager. I basically help builders, architects, installation contractors, retailers, whoever you are, homeowners, with any kind of technical questions you might have and getting into even getting the product, so sourcing and everything else. With us today, I also have Addie Atkins. And Addie, I'm just going to pass it over to you for a quick introduction as well.
Great. Thank you. My name's Addie. I am with TimberHP. I am the territory sales manager that covers Massachusetts and Vermont. So if there's anyone in those areas, feel free to reach out to me anytime. But I'm here for support in the market. So I work with architects, builders, developers. We're still doing a lot of training with the lumber yards, with insulation contractors, kind of getting everyone up to speed and ready to go with TimberHP products, wood fiber insulation.
Awesome. Looking forward to getting started with the AIA that we're going to be getting into. I did want to just have a little housekeeping. We're on a Zoom platform, so there is a chat and a Q&A. I'll be monitoring both. If anybody can, just feel free in the chat. Make sure it's hosts and panelists, and just introduce yourself and tell us where you're coming in from. So that would be great. I also wanted to wish everybody a happy holiday and New Year that's coming right around the corner, and looking forward to all your timber HP needs. So, Addie, I'm just going to pass the mic over to you, and you can get started.
All right. Great. Dan and I will kind of jump in and out of slides. So, we're going to keep it very, we'll flow with the conversation. Before we get into the official AIA presentation, I'm just going to talk a little bit about TimberHP. So you get a little backstory on us, what we're doing, what we've been working on. And then we'll get into the official AIA portion. But TimberHP, we are the first U.S. manufacturer of wood fiber insulation in North America. We are in Madison, Maine. We took an old paper mill that was shut down in 2016, renovated that, and then moved our 3 lines in. We've been getting our products out to market this past year. We've got the Timber Fill, which is a blown-in product. We have the Timber Bat, which is a friction fit bat, and then Timber Board launch, we'll say sometime summer of 2025. So that line's there, but we still have to finish the setup, commission it, start the testing, and then roll those products out to market next year. So we are excited about that. But also excited that we have 2 of the 3 out there, and that we're, seeing these products on real projects and making an impact in our markets. All right, to tell you a little bit more about TimberHP. So what is the name? What does it stand for? Timber, obviously, our wood chip is the base of the product, and then HP, high performance, healthy planet, healthy people. So from a high performance side, we're looking at R4 per 8 inch, great thermal and acoustical properties, healthy planet. We're not cutting down new trees. We are using the residuals from the lumber mills up in Maine. It is a carbon storing product and easily recyclable. It's a naturally renewable product with, as the main force, are harvested sustainably through SFI or FSC for management. Healthy people, good for the installers. It's just some wood dust. You're brushing it off yourself at the end of the day. And healthy for the occupants who are working or living in the spaces. So nothing off-gassing, nothing toxic to worry about, no waiting period before moving into a building. So TimberHP, high performance, healthy planet, healthy people. All right, and then we'll jump into the AIA portion, but still feel free to drop questions into the chat. We can keep it a little, informal. Happy to help if anything comes up as we're chatting. We will, I think when you registered, you would have given your AIA number. We will submit those and get those credits over to you. We've got 4 learning objectives in our course outline. We're going to talk about the current insulation market. We're going to talk about what is wood fiber insulation, code compliance, and then the embodied carbon and wood fiber insulation. And we've got lots of exciting stuff happening along those lines here in Massachusetts.
And then I'll talk a little bit about the current insulation market. So currently, the current insulation market, when we start looking at building codes and what's kind of happening, what's evolving, it's all for the better. We're trying to build tighter, we're trying to build more durable, and also more energy efficient, more insulation in our walls. And when we start looking back from 2003 to currently, we've seen about a 3% annual increase across the codes. Now, obviously, state by state, it depends on which code that you're adopting. But I think at the end of this, it's not just a matter of, meeting code, but actually, meeting code, maybe exceeding code, but having a durable, comfortable home or building at the end of this. And then there's a lot of more talk about, some of the other products that are out there. They're older products, and what we're coming to today is just another option, a healthy option, and better for the planet as well. So when you start looking at total market share and other installations that are out there, my background is in the mineral wool category for the most part. And, fiberglass has dominated the US market and the Canadian market for probably about the last almost 100 years now. So dating back to about the 1930s. So that's going to be obviously a big part of the market share. Then we have foams and plastic. These are typically petroleum based. There are some other ones that are not petroleum based, but there's definitely other foams and plastics out there. And then there's mineral wool, and then there's other materials out there as well. So, like I said, fiberglass 1930s. When you look at foams and plastics, they've been kind of out since the 1950s. There's sheet foams, there's spray foams, there's things like that. Mineral wool dates back to the 1930s as well. Not really in the US market until about the 50s. And you probably, if you've ever renovated a house, you're probably seeing all of these products. Cellulose is another big one where we were taking actually newsprint, so newspaper. Well, we're seeing a much lower feedstock of newspaper. So now we're finding a lot of other paper products or cellulose products in the cellulose insulation that you're buying. And then there's denim insulation as well. I honestly don't know why this one is on the screen. I don't know if anybody has heard of this one, but it has been around since the 1970s, recycling old jeans, basically. And then when we start talking about, products and getting it into, the wall cavities, the attic assemblies, your roof assemblies, one thing we always need to think about is the entire assembly and not just the one product. Because there's definitely ways to build a wall or a roof that will fail even with TimberHP products. I have not seen that because has not been on the market for very long. But typically it's all about venting, vapor open assemblies, putting the vapor barrier, if you're using a class one vapor barrier somewhere, putting it on the correct side of the wall. All of this is basically, um, a way to build a durable wall assembly. And honestly, the code, the IECC, IRC, or whatever code that you're looking at, will actually give you this recipe that makes you have a durable wall assembly. We're looking at R60 now up in attics. We're looking at, continuous insulation on the exterior plus 2x4 or 2x6 walls. And there's a lot of different recipes per se. And one of my friends, Glenn Mathewson, always talks about, how the code really does give you like a nice recipe book or a book about how to build that perfect wall. And then when we start talking about continuous insulation, which is now we're starting to see this a lot more on the market. And Addie, what are one of the biggest things for the benefits for using continuous insulation?
One of the biggest benefits is that you're like wrapping a blanket around the outside of that building. So you are reducing that thermal bridging that's coming through your two bys. As you can see in the picture there, you're slowing that transfer of heat coming out of the exterior wall.
Yeah, and this also helps with even the durability of your sheathing, because you start looking at temperature differentials, in the where I live in Pennsylvania, it started at about 30 degrees today. And well, I haven't been outside in a while, but I think it's about 50, hopefully. But basically, some days it's 30 and goes up to 70. And the temperature changes of some of these elements in your wall cavity could be detrimental to the durability of that assembly with condensation risk and other things. So that's also where putting this fleecy jacket on the exterior of your home is really going to help with the durability of your home.
And, this is something that I think builders are, slow to want to change because it does affect a lot of the other things on the exterior of the envelope. But it is becoming more and more common, in Vermont, in those colder climates, it's, much more regular that you're seeing this. Massachusetts, our code is pushing more to that now. So, there are some other things you can do, but, people are getting more and more comfortable with this continuous insulation on the outside.
Yeah, and that's also where vapor open continuous insulation also really help because to me it's like a release valve. So basically, you know, it's if there is, I'm going to use the word moisture, not bulk water. If there is moisture that collects behind like a timber board product, it's going to be able to escape. And just to follow up on one of the questions that came in, the timber board we're saying will be available in July of 2025 at this point. So we do have three product lines. I think actually the next you're going to get into that a little bit in our factory. So when
Yeah,
you start
as we
looking at,
get,
yeah.
go ahead.
I was going to say, talking about codes, this is a new 2021 code. So if your state has adopted, these are the things to look at. When you start looking at, I'm going to pull out Climate Zone 5 just because that's where I reside. You see, it's kind of like a recipe. You have many options now. You could do an R30 wall, but you're also not going to be protecting the sheathing in that wall. Sometimes it's double stud wall cavities to get to that R30 with fibrous insulations. But then also that 20 plus 5, and the 20 is basically the cavity insulation, and the plus 5 is actually the continuous insulation. So you can go back all the way down to a 2 by 4 wall and just simply put no cavity insulation in and an R15 on the exterior. And that is considered the perfect wall system, which nobody wants to ever claim that, but between Joe Stiebrick, John Strub, they all talk highly about that wall system. And then when we start talking about just tighter homes, that's something else that we need to start talking about is, we do want that air leakage to be very low. Most codes now are below 3 ACH 50. ACH is just air changes per hour. So it's based on cubic volume of your home. So if you have a 3,000 cubic or 30,000 cubic inch volume home, cubic foot, I'm sorry, that basically at 3 ACH 50, that means all 30,000 cubic feet of that home exchanges 100% of that air three times in an hour. So even that is a lot of airflow moving through your house. The blower door test I know is kind of going to be getting more interpretive as well with like a leakage rate per square foot. Talking to my friend Randy Williams, who does a lot of writing for Fine Home Building, he kind of gets a lot more into the blower door test. And then this is going back to the vapor permeable products. And, when we start looking at some of the foams and plastics are on there, if we're doing an R20 plus 5, and you only have that in, let's say, climate zone 5 or 6, you still have the risk of having condensation on the back of the sheathing. And now you don't have that outward drying potential. And that's really where the vapor permeable products do help. And then when you start looking at vapor retarder, this is as an insulation person, this is probably the question I get asked the most. And with continuous insulation, because your sheathing is warming, you don't need that class one vapor retarder anymore, class or vapor barrier anymore. Uh, and the whole guideline behind that is basically if you can keep your sheathing above dew point, you don't have any risk of condensation. So as long as that happens, and that's where even a 2 by 4 wall, if you look at that Marine 4 column, or well, any of the, let's say Climate Zone 5, continuous insulation is R5 over a 2 by 4 wall, or an R7.5 over a 2 by 6 wall. And the reason why you actually need more for a thicker cavity wall is because now you have an R22 in that cavity, making it harder for that heat to actually warm the sheathing. So that's why you actually need more continuous to keep the sheathing warm in a thicker wall system.
This chart just zooms in on those numbers and shows you that breakdown.
Yeah, and that's the code for getting into the class 3 vapor retarders, which that's latex paint for the most part on drywall. So no vapor control at all. Or vapor control, but class 3. And then Addie, you want to just walk us through this one?
Sure. So what this is just showing you is like, if you're using vapor open products, then you're reducing that risk overall in your assembly because your vapor is going to be able to dry to the inside, to the outside. And with those vapor open products in your wall cavity and on the exterior of the house, it's giving you that ability in both places. So you're not risking trapping any moisture in your assembly. If you are using a vapor retarder, like some of the smart membranes that are out there, that allows that drying back to the inside. And then as you're looking at the exterior, if you're using a wood fiber board on the outside, that's going to be hydrophobic. If it gets driving rain, that's fine. It's going to spread out and then be able to dry. And all of those fibers are encapsulated with the wax, which gives it that those hydrophobic properties. Wood naturally has capillary action that can move moisture, that just allows it to move, spread out, and dry quickly.
So Addie, how far does moisture move through wood?
Um, Good question. I
Just
mean,
look,
naturally, the tree is moving it.
I was gonna say, look at your tallest tree.
Yeah.
That's how far moisture moves through wood.
So it knows what to do with moisture. This photo I like. It's just showing you the rigidity of the wood fiber bat. It's not floppy. You can put it into the wall. You can put it in above your head. It's rigid enough to be able to walk around on the job site, handle it, and be able to install it properly. Get a nice touch all 6 sides.
And notice the gloves as well, or the lack thereof. It's not an itchy product.
Correct. No fibers, no fiberglass, nothing that's gonna poke you. All right, we're introducing wood insulation to the North American market. The big attributes is that wood fiber insulation is carbon storing. So it's a scalable product that can go across the country with high performance, great R values, managing the air and moisture, great thermal and acoustical properties, highly recyclable. In the mill, we can recycle one product back into the next. Timber fill or any of the fill products that could be even composted into your garden. These products are non-toxic, they're safe, there aren't any additives that are dangerous, and they're Class A or Class B flame spread. So we'll get into that in more detail as we break down each product, but there is a borate solution that's added for the Class A flame spread. All right, so wood fiber insulation is just coming to the US market, but it's been in Europe for over 20 years. So these are some of the major manufacturers who have been making it. A few of them have US importers. So we do see these products, on a somewhat regular basis, you could say, in that high performance passive house market. Styco was recently 50% of that company was purchased by Kingspan. So just to let you know that, these large manufacturers, building materials and insulation manufacturers are paying attention to this category of wood fiber insulation. There is a lot of excitement and interest. They see these markets growing and the need for, more environmentally friendly products in the insulation category. I'm going to play this video for you and just take note in the video, like the people are handling it, how they're working with the products, what you see them doing.
They also have some really cool tools, which you do not actually need with our products, but a lot of power tools and other things that you'll see too. Yeah, you could also see a lot of really interesting wall designs. They're putting sheathing on the interior side of the wall as vapor control, and then wood fiber board right on the exterior. I think the audio is not quite working, but that's
Okay,
okay, Addie. Don't worry about it. It's
no
just
worries. It's
fun.
background music.
Yeah. Yeah, and we're building with wood, so it makes sense to be insulating with wood as well. So, actually, fun fact, softwood has an R value, just like pine or whatever, as an R 1.2 per inch. If you look at hardwood, it's actually only like a zero point 0.3 or zero point 0.4 R value per inch because of the density of the wood. So we're making it fluffy. So, just like anything else, glass, rock, whatever, we're basically, increasing the air in between to help with the insulation. But in terms of product density, we're going to be around a 3 pound density versus, anywhere from a zero point 0.5 to a 2.3 density pounds per cubic foot.
Yeah, so, Europe set the stage for wood fiber insulation. They've been making it and bringing these products to market. Similar process here in the US. Tree is cut in the forest, that log goes to a lumber mill. It's debarked. They get as many boards as they can out of that for whether they're making dimensional lumber, moldings, whatever they're working on. It's all those little spaces in between the boards that they're cutting is the wood chip. That is their residuals, their scrap. In the past, they would sell these wood chips to the paper manufacturers up in Maine. But so many of them have shut down because, most of us read all of our news digitally on our phone or tablet these days. We're just not producing as many newspapers. We don't have the high glossy inserts that go into them any longer. So because of that market kind of going away for the lumber mills, a lot of times they burn it off. They use the energy from that. And now having wood fiber insulation being made in Maine, we're starting to, rejuvenate that revenue stream for them, and we're buying those wood chips back. We prioritize mills that are using logs from FSC certified forests. They get trucked in. Spruce, pine, fir, so a variety of softwood residuals. Those wood chips come in, enter the mill on a conveyor belt. They're steamed, they're macerated on these giant metal plates. Then a boric acid solution is injected into the wood fibers. They're dried kind of in giant pipes across the mill, packed into 25-pound bags if you're making a blown-in fill product, or get sent back into another hopper, mixed in with a fluffy polymer to bind those fibers together and create the shape with the bat. They will go into a third line to make that denser timber board.
When we start looking at our production and the capacity of our current mill, we have three separate product lines, which is very unique in the insulation category because they'll run board bat on the same line. We actually have a separate board line, separate bat line, separate fill line, and we could be running all those simultaneously, which is again increases our capacity to a point where we could literally supply probably half of the US market with our one facility right now, which is very exciting for us.
And from a wood residual side of things, we will always have plenty in Maine. So there is a lot of wood products that are manufactured. There's plenty of these residuals that are available. That will never be our bottleneck is getting enough wood fiber. And even as we look across the country, it's an issue in some areas. They are trying to find better things to do with their wood residuals. There have been states that have reached out that have asked us to come to them because they've got an abundance of wood residuals and, they want to get them off of the forest ground or have another resource for their manufacturers in that area. So lots of potential for growth across the US. A second plant someday might be West Coast, or maybe we fill in on the Southeast, depending on demand and how the sales are going and pushing. But our goal as an insulation company, as an insulation manufacturer, bringing this new category to market is to be competitive. Insulation is a very competitive line item. People aren't probably going to pay 20, 30% more because it's a feel-good story. So you got to be competitive. And that's how we've seen it play out so far in the market. We see the wood fiber fill products right in line with the paper cellulose blown-in products. From the bat side of things, fiberglass will always still be the low-cost leader, although they've increased a lot in price over the last few years because of demand. And the goal with the wood fiber bat would be to be a little bit less than your mineral wool price points. And we've seen that pretty consistently in this first year. Board, our goal will be to come in a little bit under that mineral wool price in line with the foam. That we'll see play out here in the next year, but that's our goal: come to market, be competitive, be able to take market share, and be effective on residential and commercial jobs.
And I will add too, Addie, that, with the wood chips that we're getting, we're not seeing, whether lumber prices go up or down, it does not affect the pricing of the wood chips because we're literally getting those for very inexpensive. And that's something that we're not going to see that fluctuation other than on the shipping cost. And when we start looking at, shipping, especially our bat product, you're shipping air. So, shipping to certain areas in the country will be more than others, but we're still seeing about this trend kind of in between that fiberglass and mineral product. There was one question about the boric acid that we're using. So basically, yes, it's a boric acid. It's been around for 100 years. It's basically a natural salt and it's very safe. Obviously, don't overdo it as a human, but it's not safe for insects. That's what typically it's used for. In 100% concentration, we're liquefying it and we're actually using only 7% on our products versus cellulose, which could use 15% because that's just a powdered form of it. So that's also when you're blowing it, it's actually absorbing into the wood, which makes it more of a long term. It's going to stay with the wood fiber long term.
So market position, really, it's going to be a great alternative in any of your conditioned spaces. So in your walls, your ceilings, your floors, your attic spaces, but you do want it to be above grade. So even on that exterior board, 6 inches above, you can get a little bit closer if you are sloping away from the building, but in general, it is still a bio-based product. You want to make sure it doesn't have constant moisture in contact with the product.
Yes, if your wall leaks, your biggest issue is your wall is leaking water.
Yes.
So, there was another question for kind of the sound applications. Can this be used in an exposed interior condition for sound transmission between rooms and floors, and can it be painted? So I've actually tried painting it. It is a Class A fire rated product. It's considered a thermal ignition barrier, so it can be left exposed. The bat can. And can it be painted? I've done my own, wing nut tests with just cans of spray paint, which is a solvent based. I haven't tried it with latex, but my assumption would our bat would actually absorb would hold paint very nicely because it is wood. When you get into the board product with the paraffin, that's something once we're producing it, we'll have to try. But with the paraffin, it might repel any of that paint, which you shouldn't really be using timber board or I'm sorry, our board insulation as a final finish anyway. So you should put cladding on top of that. But for the bat, you could paint it.
Yeah, and even without paint, it does have like a nice clean look to it when installed, properly in the wall.
Yeah.
Market fit wise, this is a great product for single family, multifamily, commercial, institutional, mass timber jobs, CLT, anything where you're, concentrating having a wood focus. It's just cool to be able to use, wood fiber insulation to add to that story. We're seeing more and more factory built solutions and, opportunities or modular builders that are looking to switch over. Passive house, net zero, carbon negative. People have been using bio-based products. A lot of these builders have been importing the wood fiber insulation from Europe already, so they're familiar. They're just, excited to have products that are more locally manufactured. All right, we're gonna step through each product line and just talk about a little bit more in depth. Loose fill. So the blown in product, you can loose fill, you can dense pack. So you can blow it into an attic or an attic blanket. You can dense pack into the wall cavities. You've got that softwood fiber and the boric acid solution. So there's nothing else added into that product. So again, if you wanted to, you could compost this in your garden with no issues. Boric acid is often used to balance the pH in soils. When you're dense packing, you're 3.8 per inch. If you're doing an attic install, we have an attic chart, just tells you what to blow the insulation to. Then, it has a little bit of a settling factor, and then that's what your R value is. The difference between wood fiber blown in insulation and say a paper cellulose insulation is that we both came from the same softwood tree. This product just didn't get made into paper first and then recycled multiple times. So the fiber is a little more robust, which nice parts about that is that robust fiber is going to self-support really well on the wall, and you can dense pack it at 3 pounds per cubic foot rather than going to 3.5. You're not bulging that netting and that material out of the wall, causing an issue for your drywaller down the road. So you can use a little bit less material, little different techniques from the installer side. They're going to want to move the needle around a little bit just to make sure they get everything installed properly. And they just want to make sure that they're using a double blower or bigger insulation machine wise, because of that bigger fiber. It does take a little bit more to push it. Any, legitimate insulation contractor will have a machine like that. You just don't want to rent the Home Depot machine and try to blow it in or dense pack with one of those smaller machines. The boric acid that we add to the product gives it the Class A flame spread. It's a natural mold and mildewcide and a insecticide. The pure consistent feedstock, because it's coming from the tree. Those wood chips goes through a metal screener. Everything is getting macerated on those giant metal plates. So you're not going to get trash. You're not going to have a plastic cup. You're not going to have bags that get mixed in. It is still a waste product, but you don't have that end user kind of recycle stream that throws random things into the product. Also, like Dan mentioned, say you're doing an open blow into an attic, everything's going to be dusty in that application, but we're locking that boric acid into the wood fibers. So our dust is a little bit heavier. It's going to fall a little bit quicker. It's not just the boric acid blowing off the product and fluming around.
And it flocculates in about 6 seconds after blowing too.
When we take a look at the bat insulation, wood fiber bat, we have thermal and we have acoustical bats. You've got the softwood fiber, the polyamide binder. Think of it like a polyester. When you look at it, it's like it looks like a fluffy cotton, and the boric acid. So those get mixed in a hopper. That binder mixes all the way through. It comes out in a giant sheet. It's cut to length and to width. Those products, as we're making it in the mill, say the first couple inches aren't the correct size dimensions, we can cut those off, regrind it, throw it back into the hopper. We make sizes for wood or for non-structural steel framing. So you just get an extra inch on your steel so that you get a nice tight friction fit for your 16 or your 24-inch on center. We have 3-inch through 6-inch available right now, 7.25. We've been doing some tests and had some contractors working with that, and we should roll that out January.
Yep.
So that'll be available shortly. Our 4 per inch, again, vapor open products. So if they get moisture, they get that high vapor transfer, it's going to allow it to dry back to the outside or back to the inside. Flexible, semi-rigid, you can see how they're bending the bat in the picture here. Still have the boric acid in there, so you've got the Class A flame spread, mold and mildew, insecticide, and I will show you because fire is always one of the biggest questions we get. People don't believe us when we say that wood doesn't burn. But on our website, we've got a lot of different videos. We've got some showing you with the fill product also. But as you can see, it does catch. When you pull the flame away, it will self-suppress.
One thing to also remember is melting temperature of different materials, and wood does not have a melting temperature. So, I mean, obviously, when you start talking about different melting temperatures of different materials, foams and plastics around 3 to 500 degrees where they're going to melt. When you start talking about fiberglass, you're around 900 to 1200 degrees, mineral wools around 2000 degrees, and our product that just does not melt. Not like you're going to be in that fire at that temperature, but still, it's just something that we are going to be doing some more APA testing with iJoist, and that's going to be one that hopefully we could actually get into that application in as an exposed product for iJoist between floors, like in a basement to a living area above it. So that's a test that we have slated for 2025. But at this point, the Class A rating, and we do have 1 and 2 hour fire rated wall assemblies available as well.
Yes, and we can send that ESL report out in a follow-up email after the presentation, so you've got that documentation. Okay, jumping in next to the continuous insulation board. So this is the product, again, that has not come to market yet. We get lots of calls on this. I know there is a huge demand out there in the market right now. You could use these products exterior, you could use them interior. The difference between this and the other products is it's still that same softwood fiber. There's a PMDI adhesive, think like Gorilla Glue, and then there's a paraffin wax. So that paraffin wax is going to coat all of your wood fibers, and then that PMDI adhesive is going to hold it all together, give it a nice, strong compressive strength. Sizes, the machine can make thickness from 1 inch up to 9.25. We will most likely start with 1 inch up to 4 inches. You can always layer as you need to for thicker assemblies. And we will start with a 4x8 square edge board. And then in the future, add that capacity to do the tongue and groove and smaller pieces. When you get above those 4-inch boards, they get pretty heavy. So you might want to have the smaller pieces or have something mechanically on site that can move boards around. The R value for these products is a little bit lower. So if you're R4 per inch on the back, because it's fluffy, here you want a harder, denser board, so it's going to be easier to install. So your carpenters, your sidewallers, your siders are going to be happier with that denser, harder board on the outside, because when they put their screws in, when they're trying to get that, level, they're not worrying about overdriving those fasteners and kind of creating a wavy surface. No going back and having to shim every piece of siding on the building to make sure that everything is flat and looks good. You have a hydrophobic product because of that wax, so it's going to shed moisture. I'll show you a moisture video in a second so you can see how it handles it. You can leave the board on the wall to the elements for 6 months. If it's on the roof, then 3 months. So that can handle any of the moisture, UV in that time frame. This is a Class B flame spreads to start. It does not have the boric acid in it. It might be something that we add and look to have a Class A board as we continue launching new products. But to market to start, it's going to be Class B. Still going to be great for any wood structure, 4 stories and lower. All right. It'll zoom in on this water table in a second, but just to show you, this is a demo that we do just so you can see how the water beads up. So it's going to bead up as it gets wet. It's going to kind of spread that moisture out, allow it to dry out quickly. And then just talking to the durability of the product. I mean, the picture on the upper left there, that was the College of Atlantic project. Those guys, they just left the boards on the ground in the mud for months in the gravelly, sandy dirt out there, and didn't worry about stepping on it. They're not falling through it. It's pretty rugged. And the bottom left there is that College of Atlantic project, just showing you, wood construction. You can see the zip on there. That's actually wrapped in Gutex. And then you've got the strapping, and then they're going to add the siding on after that. All right, we like to burn things, lots of burning videos on our website, but this is kind of an interesting one that you might not think about, but all those other exterior products. This first box that's burning here is EPS, goes up very quickly, that's off-gassing, lots of things. It's melting on a firefighter's head if they're trying to run through this building. There are Class A products out there on the market with foil. These ones here are very common. These next two are XPS. And then you're going to hit the timber board, the wood fiber board. And what you see here is just a really dense, hard product. I think of it like trying to burn a giant log, right? If you're trying to start your campfire, you're not going to just put your flame right on the giant log. You've got to get that fire started before that will really catch. So it does self-suppress, just takes a little bit longer, which puts us into the Class B timeframe, but still going to outperform a lot of the other products out there in the market.
And there is actually we've been talking internally about coming to market very quickly with a Class A board. It's a simple modification to our current board line by just simply adding a little borate, and it will be a Class A board. So that's something that we're hoping to deliver, if not immediately, a couple months after the immediate delivery, and that'll help us with like multifamily builds, which will be very helpful in that.
Do you want to jump back in there, Dan?
Yeah, so basically we've been talking a lot about managing moisture and how moisture move through wood very efficiently. And in a wall assembly, you are going to get some moisture in that wall, no matter what. You actually want to make sure that your product is dense enough that it can handle that moisture. And then it's considered hygric buffering and redistribution. And that's just a matter of it being able to absorb that moisture and moving it through the material to dry out. If you use like a hydrophobic product in there, you essentially could, if there's a lot of moisture, all that moisture will fall to the bottom of that wall plate, and you could get some bottom of wall rot. But that's where actually having some moisture, and again, I'm talking moisture, not bulk water, but we're able to hold 15% of our weight in moisture without losing any insulation properties, and eventually it will dry out. Typically, you're finding this happening in the swing months. So basically, when you're having that very cold morning and warm afternoon, you're seeing that moisture level increasing in the wall. And then when we start talking about thermal drift or thermal lag, whatever you want to call it, thermal diffusion, this is something that's really, really good for even in the hot months. We all over the past few years have had very hot summers, so we have one of the highest heat capacities of any other product out there on the market. And this is a little test that we did just up in our Mad Labs, Madison, Maine labs. It's a lab where we took these 3 products and we basically have a heat lamp that's going. and you can kind of see the different temperatures of underneath the first layer of material. So because it, and this is similar to thermal mass, it's basically going to be able to absorb a tremendous amount of heat. And because it is such a dense product, that's where it's really going to help with the thermal lag. So basically, it takes a very long time from it to get to one side of the wall to the other side of the wall, whereas other products will, that heat transfer will move much quicker. And that's nothing to do with R value either. So R value is a completely separate test. It's untimed, whereas this is more of that hot summer day, southern exposure of your house, sun baking down on that, dark siding, which is even bigger now, and that material is able to absorb the heat. And then when it does cool down that night, it's able to basically go back into the atmosphere. You want to continue on this one, Addie?
Sure. So we talked about having a vapor open assembly so that you're not trapping that moisture, you're not creating a space for mold and mildew. So that will be less of a chance for respiratory issues, allergies for the occupants. The next big category is acoustics. So that is a major driver in decisions about, those interior walls. How do you, have a comfortable living environment? In multifamily housing, or even just not having to hear your kids' music, TV in the next room over. So this is an STC test, which is an assembly test. So it's not product to product comparison, but it's wall assembly to wall assembly. And you'll see this first one here is a steel frame wall assembly for the acoustic bats. You've got mineral wool versus wood fiber insulation, where mineral wool, the assembly with mineral wool, everything else being, apples to apples, is STC of 45, and wood fiber insulation comes in at a 53 in the steel frame assembly. When we're looking at the wood framed acoustics, on a 2x6 wall, which is these two charts here, you have an STC of 53 and 53. If you run this same test with a 2x4 profile, you get an STC of 50 with the wood fiber bat and an STC of 47 with the mineral wool bat. So the reason for bringing this up really is, mineral wool is thought of best in class for acoustics and sound. Wood fiber bat is right there, if not outperforms in most of the assemblies. And the nice thing, it's just wood. So it's 90% wood, even with a little bit of the different additives that we put into the product. 90% softwood fibers, nothing toxic to breathe, no fibers to irritate your skin. It might be a little bit dusty, but you're brushing the wood dust off you at the end of the day. Dan, you want to jump in on code?
Yep. And then I'll jump in on the code. I'll get to, there's some questions in the Q&A, but I'll get to those in a little bit. Basically, when we're talking about code, it is approved in US. We are working on the Canadian side with our distribution partner who will be CertainTeed up there. So it's very close. We're thinking in the next couple of months, the products that we do have available will be available even in the Canadian market. But in terms of ASTM 119, E84, and other ones were approved for many different uses. When we start looking at, where wood fiber is allowed, and this is really for me more on that exterior wall. When we start looking at the interior walls, you could actually use this in type 1 all the way to type 5, because that's really, you're just needing like a 1-hour fire rated wall assembly. This is mostly for the rigid continuous insulation. So type 3 to type 5 construction. So type 5 being your residential builds, type 3 typically being your multifamily wood constructed building. So basically anything built out of wood, you'll have no issues on the exterior side, but interior, you have no issues whatsoever.
All right, and then we're going to jump into the embodied carbon and the impact of wood fiber insulation. So this is kind of a generic life cycle analysis based on wood fiber insulation being manufactured in the US, in Maine. on the Kennebec River with hydropower, so generic but specific. This is kind of an early on life cycle analysis before manufacturing began, and then we'll redo this. Recently, we're awarded a grant from the EPA to do our EPD, which would contain the life cycle analysis. So all of that work will be redone as manufacturing capacity grows. They do need a year worth of, actual energy usage for those to be effective and viable. So that will be updated shortly, but more info to come. And, why does it matter? I mean, if you take a look at the built environment, there's a lot of energy consumed in buildings. So, globally, 39% comes from buildings, and 8.2% of that impact is just from the materials in construction. So that's that embodied energy that we're talking about. And with that 8.2, we're looking at that embodied carbon and trying to understand that better. Where are these products coming from? How do we calculate it? We're looking at the life cycle analysis, the EPDs, so that we can compare products and really understand how to lower our embodied carbon as we're building. And the focus moving to embodied carbon is that we've done pretty good with the operational energy. So, we've gotten a better idea how to lower that, but now we still have this other, are we importing everything from Europe? Are we using energy intensive building products to, be more efficient? What can we do with more, bio-based products that are locally available to have a greater impact? And part of the problem, or I guess reason I would say that we haven't gotten a lot of solutions earlier, is that, the insulation market's been really struggling just to keep up with demand. We're using a lot more insulation. We're using more insulation on the interior and the exterior walls. And so these manufacturers have been just kind of trying to keep up. And they haven't made a whole lot of progressive changes. There's been some have clean themselves up a bit. But in general, they're typically still high embodied carbon, vapor closed products, not recycled, with things that are off gassing. So what we'd like to bring to the table as a solution is wood fiber insulation. So you've got a carbon storing product that can be used in construction to, yield a net benefit in the atmosphere. And this is a natural process. So nothing, that we have to mechanically tell the tree to do out in the forest, but, through photosynthesis, that tree is going to pull the carbon dioxide in. It's going to send oxygen out. As that tree moves through its life cycle, if it's cut and used to be made into lumber, that's great. That lumber is going to go into a building and it's going to be there for 100 years. But do you let those scraps, the pieces that didn't make it into that 2x4, rot and decay? Do you burn them and allow that CO2 to go back into the atmosphere? Or can we take those wood residuals, make them back into another high performance product, put them in the wall, and continue to store that carbon for another 100+ years? So that's how we see wood fiber creating a great solution. And that carbon footprint, I mean, if you take a look at some of the data, wood fiber insulation, because of its carbon storing abilities, is going to be carbon negative. When fiberglass, it's not the worst offender, but it's also not the most effective product for thermal and acoustical. When you look at mineral wool, you're starting to get into those higher embodied products because you're mining a rock, you're melting it, and then you're fluffing it up into cotton candy. So you've got, multiple steps there. Spray foams, the foam boards, those are oil-based. They're off-gassing things into the atmosphere. So those start to get into those higher embodied carbon numbers. And then we've got a quick walkthrough of the embodied carbon of a 1,500 square foot passive house wall assembly. And I'll just kind of flip through these for you, but this is just showing, say you move from a mineral wool to a wood fiber bat in your 2x6 wall, and then you make the change on the exterior. You go from a mineral wool board to a wood fiber continuous board on the outside. Now you essentially have saved in one house the equivalent emissions from driving one car for 2.5 years. So if you're thinking similar thermal, similar acoustical, similar price point, but you have the ability to make a huge impact on carbon emissions from these products or the embodied carbon from these products, you know, you can make these big decisions. And insulation, we're not the only category out there that is looking to reduce its embodied carbon. Concrete, of course, is one of the biggest offenders. They've been putting a lot of work in the last few years too. I'm sure you've seen many of the studies and the opportunities to make changes in those categories. But it's something that we're kind of looking at across the board. And in Massachusetts, if anyone is in Massachusetts, we actually have something that's being added to our building code in the HERS rating category for if you use low embodied concrete or insulation with low embodied carbon. So we're being incentivized. You get 3 additional HERS points on your new construction builds if you make these choices. And, Massachusetts is, I would say, one of the states that's leading the way to kind of reduce their carbon footprint. And we'll be the guinea pig, I guess, and go first, and then the case studies will come after to see the impact that we can all make in the built environment. And that is us for the official AIA questions. Dan, I think you said there was a few questions that we haven't covered yet.
I did. I was able to cover them in the chat. You could go into the Q&A. I could bring a couple of them up. One was basically, can timberboard be used on a low slope flat roof application? Will timberboard be tapered? Basically, right away, it's going to be only good for like a residential roof, but hopefully down the road we'll get it tested for flat roof applications. The tapered part, again, that's probably a whole nother machine. I'm sure it's possible, but it's not something that's in the initial line. If you wanted to, you could look into like a hybrid system where you're using a tapered product with our product, and then that way it will be a tapered roof at the end of the day. So, and then another one that came in was typical cost comparison between our like 3-inch bat versus Safe and Sound. So if you want to handle that one, at least in your market in the Massachusetts and Vermont.
We see the pricing is like, I would say maybe 8% less in our market, depending on, where you're buying it through.
Yeah.
And we do have a where to buy section on the website, so you can see who stocking dealers are and distributors if you're an insulation contractor or lumberyard looking to purchase.
Yeah, and thank you for all the suppliers that are on here today too. I'm seeing a lot of them in the chat and also just the names that are up there. So thank you for continuing to support us and selling our product. So, and that's pretty much it. So we're kind of out of time. It's 2 p.m. Wishing everybody a happy holiday and very happy new year. Hopefully everybody gets some time with their friends and family over the holiday season, and Addie, you too. Happy holidays, happy new year.
Thank you.
And we'll see you next year. In January, we're actually currently putting together our schedule for these roundtables, Beyond Our Values, Behind the Walls. So we're probably going to be getting more into like application specific, beginning in the crawl space, going our way up. But then other discussions. So if you go onto our YouTube page, you could for TimberHP, you could see even the last one. I have a good friend who's on right now, Dan Hines. He was on that one. He's a passive house builder down in the Washington, D.C. market, and he really wants our timber board, and I know that very well. So, but till next time, everybody, have a great day.